All right, today should be hopefully pretty easy. There's not too much crazy stuff going on with today. We're going to talk about Extrema, which is a fancy word that you probably haven't heard of before. Basically, what Extrema means, it means extreme points. So if I'm looking at some kind of graph, I'm looking for the extreme of that graph, which means finding like a maximum value or finding a minimum value, which is going to be pretty simple. Okay. For our work, let's say I've got this graph, something like this, and like this. Now, let's say I'm fixed on this interval, and we'll say the interval here is 1, and then I went up 2 right here, and then I'm at, let's say this is 2 right here, and then 3, and then this would be up here at 2 and 4, something like that. Okay, so I just have some generic graph up here, and I want to find what they call extrema, which is a maximum or minimum value. What's the extreme values of this graph? What's the highest value, and what's the lowest value? That's kind of what we're looking for. Okay. A couple things that will change about this. The highest value that's on this actual graph right here is whatever the highest is on the y-axis, and that would be this point right here. This point right here they would call a maximum value. Okay, so we'll just say max. Easy, right? Okay. The minimum value is the lowest value on the graph, which would be this point right here. Okay, so that point right there they call the minimum value. Okay, so if I ask for a maximum value, just give me the point. So the point for this one would be 3/4. The maximum value is 3/4. And the minimum value would be 2, 1. Super easy, right? Nothing crazy going on? Okay? Now that's on a fixed interval, okay? That's on a fixed interval from 1 to 3. And they'll write this way. They'll write the interval as this, 1 to 3. Remember that interval notation? I think we've talked about it a little bit in pre-calc, I think, maybe? Maybe. It's been a while. It's been a long time, okay? Interval notation means that my x values are going from 1 to 3, okay? So I'm confined to this little space. Let's say the graph continues and keeps going and does other stuff. I don't care. I ignore all the other stuff and I focus on from 1 to 3. Okay, so that's like our little interval for that. Now let's say this changes just a little bit. Let's say I've got this exact same graph, except for I've got a point here, and I swing down here, and then I go open circle up here. Okay, and then my interval for this one, and I'm going to use the same exact values right here, but my interval is still going to go from, let's say, 1 to 3. And then now, instead of having a square bracket on the end, they'll have a round bracket, which means the point on the end is not included. Okay, so we want to find the maximum and minimum values here. Okay, we want to find the extrema. Extrema, tomato, whichever one. I always say extrema. But anyway, if I want to find the minimum and the maximum values of this guy right here, so I want to find the highest points this graph is going and the lowest the points this graph is going. What's the minimum on this one? Same as before, right? It'd be this point right here. That's still the minimum value. Okay. Now I want to find the maximum value. So what's our maximum value on this one? It's what's that?
So the one below.
Yeah. Which point is right below that?
Infinitely close.
Yeah, we don't know, right? It's not one exact point right here, so this one has no maximum. Okay, so it doesn't have to have a minimum, and it doesn't have to have a maximum. Okay, but it has to be a specific point for you to actually have either a maximum or minimum value. Okay, so this one would have no maximum for that. Okay, yeah.
So you could actually say you have a question that says find the maximum of a graph with, and then it shows the brackets of 1, 3. You could just read it from there.
Exactly.
If you have that. If you have a rounded edge, there's no max on it.
Amen. Perfect. Perfect. Assuming that that's the highest the value goes, right? Now let's say I had a graph that goes something like this, and on this end it's an open circle, right? Right? Why would I have a maximum on that one? Sure. Even though my endpoint is open and this endpoint is open, right? I still have a maximum value, still have a minimum value. This right here would be my maximum value, right? This right here would be my minimum value. Okay? Make sense? Okay, so just because it's an open circle doesn't mean that we don't have a max or a min. Now, if that endpoint's at the highest, then yeah, we wouldn't have a max or min. Okay? All right.
Will they always give you a graph, or what if they?
No, but we have these things they call graphing utilities, and we can utilize them to the best of our abilities. Okay. Now we're going to do a lot of stuff without them, but there are some tricks and tips that I'll show you with this. That we can do. Okay. All right. So that's the second type example. Third one, just real quick here, is let's say I'm going this exact same graph again, right? And I'm going from now I'm going to go from interval 1 to 3. And so I'm going to have an open circle right here. I'm going to go down here. I'm going to go open circle. And then I'm going to go here and then open circle. And then I'm going to put my point right here. Okay, and I want to find the maximum value and the minimum value for this one. I want to find the extrema. Does not exist. No extrema. Okay? Feel pretty good? Yeah.
So now, would you be able to read it straight from that?
Yes.
Okay.
Yes, you would. And there's some in your homework tonight where they're just going to give you a graph and say, look at this and tell me what you think. That kind of thing. Like find a max, find a min, that kind of thing. Okay. All right, cool. All right, I'm feeling pretty good so far. Now, what about, let's say I have, let me do this one right here. Let's go ahead and do x to the third, and then minus 3x squared. And we'll say this is our function. So we'll say, let's call this f of x. And I want to find the extrema. Which means find the maximum values and the minimum values for this. Well, let's first just go ahead and throw that on a graph, see what it looks like.
Radian or degree?
If it's a polynomial, it doesn't matter. The only ones it matters for is if it's a trig function and then radians.
Okay.
Okay. I think I'm in radians right now. So x to the third and then minus 3x squared. And just zoom 6 to find it for the first one. The graph looks something like that. Feeling pretty good about that. So as far as my graph goes, I've got, let me just ballpark it. Okay, it's just ballpark. Okay. Now for this one, I want to find, and I'm going to do this in open interval, okay, which means my interval is going to go from negative infinity to infinity, which means I want to look at the entire graph. Okay. So I want to find extrema, I want to find a maximum value, and I want to find a minimum value. If I were to just look at that graph right there, what are the maximum values and the minimum values?
Infinity.
Yeah. Give me one specific point.
No.
There isn't one, right? There's no maximum or minimum value. That graph goes up forever and goes down forever. Okay, so there's no what they call those absolute maximums and absolute minimums. Okay, so this one has no absolute maximum and then no absolute minimum. Now, just looking at that graph, though, you're probably thinking, wait a second. It looks like there's possible points where it could be a maximum or minimum. Connor?
I have a question about the point not included.
The point not included. Okay,
Yeah.
like on these ones.
Shouldn't the value just be the x value minus 1 divided by infinity, because that's the closest value to the...
But that's still not a specific number, though. Right? Infinity is not a number, right?
It's as specific as you get to the
It's not a number. Yeah, I can always think of a number bigger than infinity. Infinity plus 1. I win. It's not a number, right? So, for it to be an absolute maximum or minimum, it has to be a point. It has to be a point that I can graph. You can't graph it. No matter what, I can always put a point closer to here. We're just zooming a little more, and I can get a little closer. So we're just kind of bobbing around. We don't know exactly one point, so we can't call it a maximum or minimum at that point.
Okay.
Does that make sense? Kind of. Yeah. So, yeah, 0.9 repeating. So, yeah, but I could always add another 9, you know. But then it's not a fixed value, right? That's not. Yeah. Anyways, so now this one has no absolute value, no absolute maximum and no absolute minimum. Okay. Now that doesn't mean on this graph doesn't have what they call relative maximum and relative minimum. Okay. And that means if I were to look at this graph, anywhere where it has what they call hills, okay, so if it has a little knob right here, see this little uphill, they call this a hill or they call this a valley. If I have a hill right here, this point right here can actually be called a maximum value. Okay? This point right here can be called a minimum value. Okay? Now the problem with that is this is not the maximum value of the entire graph, right? Obviously there's values higher than over here. This can't be the minimum value of the entire graph because there's values down here. So they're going to call these relative maximums and then relative minimums. So it's relative to a specific zone, a specific interval that you want to call. So I can call this a relative maximum as long as I fix my own interval. So if I make my interval from here to here, let's say negative 1 to 1, right? Or maybe that'll work. Yeah, negative 1 to 1. Negative 1 to 1, I'm going to have a maximum value at that interval. Okay, but I fixed the interval, which now makes it a relative maximum relative to what I decide the interval is going to be. Okay, this one's relative minimum, exact same reason. Okay, we feeling okay about that? Not too bad. Now, on our calculator, we can find those values pretty nicely, called relative max, relative minimum. If I just look on my graph, I can kind of assume that 0, 0 is 1. But if I go to my calculate screen, if you notice, number 3 and 4 are minimum and maximum. Awesome. So we can use those now. Okay, so maximum number 4. I just hit number 4. It says get on the left side of it. So I get on the left side, hit enter. Get on the right side of it. Enter, and it says yes. You don't need to guess at all. So you can sit in there again, and it'll find it for you. Cool. Now this is 1.45 e to the negative 6, which is pretty much 0, right? That's really, 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 really small. Okay. Calculator just runs out of stuff to calculate. And then negative 6 e to the negative 12. Once again, that's 0. Okay. So the relative for this one, the relative max is going to be at 0, 0. And then the relative minimum, we're going to want to find the relative minimum, and we find it the exact same way. We want that minimum value, looks like it's at 2, negative 4, 5, somewhere in there. So second calculate, second calculate number 3 is minimum. And I'm going to get on the left side of it. Are you there? Get on the right side of it. Got it, and then enter, and then it tells me that it's at 1.9, which is around a 2, negative 4. Okay, so we got 2, negative 4. Okay, so 2, negative 4. Yep.
Mine comes within so close to yours, but it's like mine says 2.00, all the way is.
Mine's better.
Is it? Because I mean, if I get duped.
My batteries are fresher. I've no good answer. They're all just a little bit different. I might have more in the memory, and so my little memory, usable memory might be a little smaller, or yours might be a little smaller depending on how many games and things you have on there. So you'll get a little bit different numbers just based on that. So yeah.
Why is it not 2? Because if you plug it in, wouldn't that be?
You should, and you could do that as well. You can do a second calculated value and plug in 2, and it gives you negative 4.
But why is it not?
Why is it? Because of how they calculate the zeros. We'll learn how that works later. It's called Newton's method, and we'll get there later.
We have to learn about Newton.
We'll get there. We'll get there. Newton's done way too much for us. You know, that guy's pretty smart. So. All right. Anyways, let's go ahead and keep going now. Keep going. We got a little bit more to do. As I look at this graph, right here, let me talk about the calculus stuff that we've been doing. Everything we've been doing lately with calculus has been to do with the derivative. So far in Chapter 2 was all about how to find all these different kinds of derivatives. Okay? Chapter 3 is all about applications and different uses of those derivatives. So she's not here today. Sorry, she's not here. All right. So what we've been doing lately is derivatives. Now, what does a derivative find for us? The slope. Okay, so what's the slope at this relative maximum at this hill? 0. What's the slope at this relative minimum? 0. Cool. Okay, so if we can find out where the slope is 0, or where we have, I think the quizzes use the terms horizontal tangent. Isn't that what they use? Yes. Everybody's nemesis, right? So if I want to find a relative maximum, I want to find the derivative. And I want to find where the derivative equals 0. Wherever the derivative equals 0, I have what's called, they call them critical points. And that's potential spots for where we have a maximum and minimum value. Okay? So if I were to take this function right here and find the derivative of it. Okay? So let's say I take the derivative of that guy, which hopefully we're just derivative machines now. Derivative of that would be, what, 3x squared and then minus 6x?
I figured I'd use the dydx.
Cool.
What?
Okay, so that's my derivative, and I want to find out where this has horizontal tangents. I want to find out where my possible slope right here is 0. Okay, so right here I just set this equal to 0. So I'm going to go 3x squared minus 6x equals 0, and I want to solve for this guy. Okay, what this does is this solves for what they call critical points. Okay, critical points are potential spots where we have a relative maximum or minimum. Okay, all right, so I'm going to solve this for I got a factor, so take out a 3x, and then you're left with what, x minus 2. Equals 0. And then figure out what makes each of those guys 0. So that'd be 0 and then a positive 2. Okay, so 0 and positive 2, those are called critical numbers. Critical numbers. Okay, critical numbers happen wherever the slope is 0 and actually wherever the slope is undefined. So we'll take a look at one of those as well. All right, cool. So these are my two values right here. These are critical numbers. Now what I want to do is I want to find out what my maximum and what my minimum values are going to be. Okay. So for this one, 0 and 2, those are my possible x values. I just can plug those in, right? Plug those 0 and 2 into my original function right up here and get my values. Now notice it's going to be the exact values as those right here. X is 0, when x is 0, y is 0, and then when x is 2, y is negative 4. Okay. And those are my relative minimum and relative maximums. But that's where the slope equals 0, and those are called critical points. Okay. Feel pretty good? Okay. Now, if I have a maximum, the maximums only occur at critical points. Only time they occur. Okay. So you can't have a maximum or minimum that doesn't occur at a critical point. It's impossible. Fancy proof for that. Go for later. Okay, critical points are the only spots where relative maximum and minimums happen. Okay, all right, so let's go ahead and find some extrema. Let's go ahead and do one on this one. Let's go ahead and do f of x equals 3x to the fourth minus 4x to the third. And we're going to put this one on an interval. We're going to go from -1 to 2. Reload it here for you. You guys all get a graph for doing all that stuff. All right, let's go ahead and find our critical points. That's the first thing I'm going to want to look for. Okay, so let's find our derivative of this guy, which is going to be what, 12x cubed, and then minus 12x squared. Okay, so those are my, that's my derivative. That's going to find slopes for me. And I want to find critical points. And critical points happen wherever my function equals 0, or wherever the function is undefined. Okay, those are the two spots where critical points happen. So I want to set that equal to 0. Set that equal to 0, and I've got, let's see, I got a factor here, looks like. So I'm going to take out a 12x squared, and then you're left with x minus 1 equals 0. So we have some critical points here. We have critical points at 0 and at 1. Those are my critical numbers. Okay, so 0 and 1, that's where it's going to happen. This one happens to have multiplicity. It happens twice because it's x squared right there. Now what I want to do is I want to find out which of those values are going to be my maximum and which of the values are going to be my minimum. And keep in mind we're on the interval from -1 to 2. Okay? So if I were to look at my graph, and I zoomed in once, yours might not look exactly like that. Should I zoom out to your guys'? Sorry. Just thought it might have been a little easier to see.
Yay.
All right, looks pretty good. Okay, so what I want to do, and I'm just going to throw the graph up here just so I have it up here as well. Okay, but it's going to go something like that. So that's what my graph looks like. Okay, now if the value is 0 right here, that's the x value 0 right here. Do you guys think this is a minimum or a maximum value? Trick question, neither. Right? It's not either of them, right? That's not a minimum or a maximum value. Look at where your interval is. Okay, interval is -1, which might be somewhere in here, out to 2, which might be somewhere. I'm not sure where the 2 value is. It's going to be up here somewhere. But anyways. So those are my values. Okay. So actually, this one right here, it is a critical number, but that doesn't mean it's a relative maximum or minimum. Just because it's a critical number does not mean it's automatically 1. Okay. So we might have a whole big list of critical numbers, and you might only find 1 or maybe 2 in there that are actually maximums or minimums. Okay. So on this one, is one of them a minimum or maximum? Let's see. Let's type that in. Second calculate value 1. And I get -1. Looks like on my graph that that's the minimum value. You could go calculate minimum and then guarantee that, but it looks like I have a relative minimum, and the relative minimum on this one is going to be what's that? -1. Now this one I'm calling it a relative minimum, but wouldn't this actually be an absolute minimum as well?
Yeah.
Right? There's no points that are ever going to go lower than this, right? The right side and left side are going to continue up forever, and there's no point that's ever going to get lower than this point. So this point right here, you can call a relative minimum, and it's also an absolute minimum, okay? So that means there's 0 points that will go lower than that, regardless of the domain, or regardless of the interval domain that I'm on, okay? Now, what about my maximum? What about my relative maximum? I don't have any more critical points, right? But I do have a maximum value. Somehow I have to have a maximum value. Which point's higher? Is f of -1 higher, or is f of 2 higher? Right? Because my interval, my endpoints can count, right? If I remember back to my first little mini graph I did, if it's an endpoint, right, and it's the highest value, that's a maximum value, okay? It doesn't have to be on a hill or on a valley to be a maximum or minimum, okay? So let's go ahead and type in the values real quick. Let's go ahead and go second calculate value, and I would go -1. -1 gives me a value of 7, okay? So a -1 is up at 7. I know graph, not the scale. Not drawing the scale. Now let's do 2. Let's go ahead and type in 2, and I get 16. Okay, so which one of those is the maximum value? 2. Okay, 216 is my maximum value. So 216 is, and this is also an absolute maximum for the interval -1 to 2. I'm going to call it a relative, absolute max. Sorry. Okay, that's the highest that graph could potentially go. Now that means that my graph obviously didn't draw up perfect, but that means that this point would actually be up here somewhere higher than that point. Call it good.
But that's not a relative, that's an absolute.
That'd be an absolute because I'm on a fixed interval. Exactly.
So what is the,
So there's no relative.
So there's not a relative maximum on this one. No, I guess you could call every absolute maximum a relative maximum if you wanted to. It's relative to that interval, so it's kind of up to you. Yeah.
so why is the maximum, why didn't it come from the critical numbers?
Why didn't it come from a critical numbers? Oh, because the critical numbers show me where I have a slope of 0, right? This point right here doesn't have a slope of 0, right? So that's where these numbers even came from. This one just happened to be the end point of my interval, which I also want to check for my maximum and minimum. The maximum doesn't always have to look like a maximum or a minimum. Okay.
So you use the critical numbers and the
I use all of them. I use the interval endpoints and the critical numbers, and I find out which one's the highest, which one's the lowest, and that gives me the maximum and minimum on that range. Okay. Cool. What's up? Absolute means that there's no points in the interval that can be higher. Relative means that it could be a high point, it could be on a hill, but not necessarily the highest point in the interval. Does that make sense? Okay. All right, cool. Let's do. We got two more to do real quick that are a little more challenging. Those have been pretty easy polynomials. Some take a little bit more work. But the general idea, this is what we're looking at, this general idea here. So we got 2x, we'll go minus 3x to the 2/3, and we'll go interval, -1 to 3. And notice I put square brackets on my interval, which means they can be included. If those brackets weren't included, then I wouldn't have the maximums I had in the last one. So go ahead and see if you can find some critical points there. Friendly reminder, critical points happen where the slope is 0 or where it's undefined. Ooh, I better make sure my window is in the right. Hold on, let me change the window just a little bit. I'm going to go X max to 3.5. That way I can check my endpoint values. Now this has probably been a little while, but I'll throw this little graph on here like so. Looks like my graph is going up like this. And it bounces like this. Something like that. Okay? Now if I look at this point right here, what's the slope at this point? It's undefined, right? That's a sharp turn right there, okay? Slopes, we can only think about slopes when we're having a nice smooth turn, okay? So I might have like a minimum value right in here somewhere, whatever that value might be. But this value right here, the slope of that's going to be undefined, okay? I'm at a sharp turn. Anytime you're at a sharp turn, the derivative of that's undefined. The reason is because this slope's getting closer and closer and closer to one specific number. This slope's getting closer and closer to a specific number. They're not going to the same number, unfortunately. They're going to the same concept. Which Connor hates, but they're not going to the same number. Great, so let's take the derivative of this guy. So we're going to go f prime of x. It's going to be a 2, and then minus, let's see, derivative of this is going to be 2x to the negative 1/3. I believe. Is that right? Yeah. 2/3, 2x. Yeah, that's pretty good. Okay, so I want to find out where this guy equals 0 or where it's undefined. So those are my two options right now. I'm going to simplify this a little bit, just try to combine those like terms if I can. This is 2 minus 2 over x to the 1/3 power. And then I would want to add those together if I could. You can get it down to one term, life will be a little easier for you usually. Okay. So I need a common denominator. So a common denominator here is going to be an x to the 1/3 and an x to the 1/3. So I've got a 2x to the 1/3 minus 2. Divided by x to the 1/3. Okay, so that's my derivative. A little bit simplified. I know it doesn't look it, but it is. Okay, now I want to find critical numbers. Now critical numbers are wherever the function or the derivative equals 0, or where the derivative is undefined. Okay. Well, first off, where is this guy undefined at? 0. If I plug a 0 in, the denominator becomes 0. That's undefined. Okay. So 0 when x equals 0, that's a critical number. That's where the derivative equals the derivative is undefined or 0. Okay. The other one is where the numerator equals 0. If I can make the numerator equal 0, 0 over whatever is going to be 0. And we'll be able to simplify that just a little bit. Okay? So what's my value if I were to solve for this guy right here? 1. Should be a 1. Okay? So those are my two spots where I'm going to have critical numbers. Okay? The first one was where the bottom equaled 0. That was pretty easy. It's just 0, right? That's where it's undefined. The second one is where my top is going to be equal 0. Horizontal tangent. Okay? Those are my two critical numbers right there. And I think those are my only two critical numbers, okay? So now what I do is I check to see which one of those is going to work, which one's going to give me the maximum, which one's going to give me the minimum. Looks like this point right here is my maximum value. That's at 0, and I'm just going to check that real quick. So I can calculate value and go 0. I get 0, 0, so it actually does touch all the way up there. Sorry. So at 0, 0, 0, 0, I have what they call, this one would be a relative maximum, okay, relative to my interval. So in this little window right here, it's a maximum. It might not be the absolute maximum yet. I still have to check the endpoints. Okay, this potentially could be up here a little higher. So we'll have to check the endpoints. But that's a relative maximum. Okay. Let's see. What about my other point? 1. Let's go ahead and type in a 1. I get -1. That looks like a minimum point right there, right? So I've got the point 1, -1. That's a relative minimum. Okay, and now to find the absolute maximum or the absolute minimum, the highest the graph will go and the lowest the graph can go on my set interval. The set interval is going from -1 to 3. So those points I want to check real quick. I want to check f of -1, and I want to check f of 3, and I want to see what those values are. Maybe they're bigger or smaller than the 0 or -1, and we'll check it out. Okay, so let's type in -1. -1 gives me -5. Okay, so -1, -5. And then let's plug in a 3. 3 gives me -0.24. So -0.24. Okay, so that's my right endpoint. My right endpoint is at 3, -0.24. Okay, so would that be the maximum value? Is that the highest the graph goes? No. This graph is higher, right? So this is not only a relative max, this one's also an absolute max. Okay, this one happens to be both. Okay, this one is none. That's nothing. This f of -1 and -5, what would you guys call that? That'd be your absolute minimum. Okay, so that's the lowest that graph can go. And that's on the fixed interval, -1 to 3. Okay? Getting the idea? Sort of? Okay. We have room for one more, but I'm a little tight on time. Yeah, we got it.
So the relative minimum
I'm going to try.
over the interval, but like the absolute minimum, it's over the interval.
No, the relative minimum is over an interval that you choose. So if it has like kind of a hill or a valley, okay? So like this one right here, I called this a relative maximum because in this little window right here, in my own little world, it's going to be the highest value there. Okay? Now, on the interval -1 to 3, the -1's down here, right? That sounds good on my there. And then the other interval 3 was like right here, right? Now this technically is still the highest value, like pretend that this isn't here and this isn't here. That's still the highest value that's there. So that's also an absolute maximum. Okay? Relative to this window, absolute to the entire interval. Okay? This point right here, we call the relative minimum. Okay, but that's not the lowest the graph can go, right? That point is. Okay, so this right here was called the absolute minimum. Okay, on the entire interval.
So I have to find the relative minimum.
Because it's good to find. Later.
Okay.
We'll get there. We shall get there. Today is the how-tos. Later will be the applications. And you guys will hate the applications when we get there. It's kind of like the, it's kind of like related rates, right?
Oh, yeah.
You don't think I have time? I so have time. I'm going to go right to the bell, but I so have time. Okay, let's graph this. I would recommend this in radian mode. Just FYI. So make sure you're in radian mode. You'll probably get like a line if you don't put it in radian. It'll look just gross. Okay, now real quick, my interval is going from 0 to 2 pi, okay? So I'm going to draw a little bit. My interval starts at 0. That's my left endpoint of the 0, okay? My right endpoint, second calculated value. 2 pi is my right end of my interval, and that's 8 point something, okay? So right here is the endpoint of my interval. So I'm only concerned on this little region right here, okay? So if I were to look at that region, just as far as looking at the graph goes, right? What would my relative minimum, relative maximum be? Looks like I have a maximum value right here, right? That's a relative maximum. Looks like I have a relative minimum right here, okay? So those as far as my hills and valleys, okay? Now I want to do absolute maximum and absolute minimum, okay? The absolute minimum on this one, it looks like this point right here is going to be the absolute minimum as well. You guys okay with that? Okay? What about the absolute maximum? The right endpoint, okay? So the right endpoint is probably my absolute maximum. This one's relative maximum. This one's absolute maximum, okay? The absolutes, or sorry, the endpoints right here do not happen in critical numbers necessarily, okay? Only the ones that are relative right here, those are the ones that happen at critical numbers, okay? So if I were to do this, if I were to solve this just real quick, I would do the derivative of this guy. Let me just make sure I can match up to that, okay? I would take the derivative. It would be 1, derivative of 2 cosine is negative 2 sine. So I'm going to go negative 2 sine of x. Okay, that's my derivative. I want to find out whether this is either 0 or undefined. Sine is never undefined. It's continuous all the way through, right? So I'm just going to find out whether this guy equals 0. So I'm going to set it equal to 0. And I would solve that. So I would add 1 and divide by negative 2. Give me sine of x would equal a positive 1/2. And I want to find out where the sine function equals positive 1/2. Okay, so what I would probably do is just build a little triangle right here. Sine's opposite and hypotenuse, making this a square root of 3, making this angle 30 degrees. 30 degrees is pi over 6, I believe. Okay, so I'm pretty sure pi over 6 is where one of my critical numbers is going to be. Okay, the other spot where sine is positive, it's been a long time since you guys have done these little triangles, huh? The other part where sine is positive is up here. So I'd actually build the same triangle, that'd be 30. So actually from here to here would be my other angle, which is, this is pi over 6, so that's going to be 5 pi over 6. So pi over 6 and 5 pi over 6, those should be my critical numbers for that. Okay, that's where the sine of x equals 0. X equals pi over 6 and 5 pi over 6. I know I went fast on that, but we're kind of on crunch time for time. Sorry. Okay, so let's go ahead and check those values just real quick. Second calculated value. Nice thing is you can just plug in your pi's here. Just plug in a pi over 6, pi divided by 6. And I get, looks like that maximum value that I just wanted, right? 2.25, okay? And then check 5 pi over 6, 5 pi divided by 6. And I get that minimum value that I want, okay? So I checked it with that. You can graph it. You can do your relative min, relative max, and feel pretty good about it. And you guys are good with finding the endpoints and gist of it we're getting, I hope?
So in this one,
So sorry for rushing through that last one. I apologize.
So with the relative and the absolute, inside the interval.
Let me write this down. Yeah, hold on. Just so people have a chance to write it down.